Now, sometimes when we have very large data sets, but the data is discrete, which means discrete just means that the values were counted, or if we have data that is continuous data, which just means that the value was measured. But in both cases, we're tracking data that is numerical. We sometimes have to create classes that are going to be intervals of values. Now, a couple of things to keep in mind when you're building classes that are intervals, that each class has to have the same width, which is how wide or how big the interval is. The classes cannot overlap, so it must be very clear where one class ends and the next class begins. And you're typically going to want between 5 to 12 classes to best summarize your information and to make a graphical display. When you get sometimes more than 12 classes, for some people it's kind of hard for them to be able to visualize what's going on. And if we get fewer than 5 classes, we sometimes can't see good trends or patterns in the data. So I have 2 examples of data that's been organized into classes that are intervals. So on this first example over here, the data that's being organized is ages, and it's being broken into, over here I have 4 classes. The classes are 25 to 34, 35 to 44, 45 to 54, and then 55 to 64. So you can see that there's a whole range of values in each class. Every class will have what's called a lower class limit, which is where the class starts, and an upper class limit, which is where the class ends. So these values over here on the left, the 25, 35, 45, and 55, would be called the lower class limits. And then these values over here, the 34, 44, 54, and 64, are the upper class limits. So for instance, the first class has a lower class limit of 25 and an upper class limit of 34. And then you can see over here, this is the number in thousands of individuals that satisfy being that age. All right, so over here we're tracking our frequencies. One of the other things that we can look at when we're looking at data that's being organized in intervals is the class width. So the class width, which you can think about as how big each class is, how we're going to determine that is we are going to find the difference in consecutive lower class limits. So we're going to find the difference in consecutive lower class limits. Well, that may be the class width. There's a lot of math words to unpack there, right? Okay, so let's go ahead and unpack them. So difference means that you're going to subtract 2 values. Okay, so that's what difference means. Consecutive means one right after the other. And then lower class limits, well, we know how to identify the lower class limits. So coming over here, you would grab 2 different lower class limits, and it doesn't matter which 2 consecutive ones that you grab, it has to be one right after the other. So I'm just going to grab the first 2 I see, the 25 and the 35. And I can use those values to compute the class width. I'm going to take the difference or subtract them. So 35 minus 25 is 10. So the class width is 10. And if you were to sit here and look at this, you can see that, yep, every one of these classes has a range of going up through 10 values before we break it into the next class. Let's take a look at another data set that's being organized into classes that are intervals, just to kind of show you how we could get a little bit of variety. So I have a frequency distribution over here. In this frequency distribution, there are 1, 2, 3, 4, 5, 6, 7 classes. The first class has a lower class limit of 10, and an upper class limit of 11.99. So we're starting to get into some decimal values on these ones. So remember, the lower class limits are where the class starts, and the upper class limit is where a particular class ends. When we give these, we have to be very clear about where a value falls, and that's where the decimal stuff comes in. So if I get a value of, for instance, say, 12 exactly, that's obviously going to be in the second class because the first class ends at 11.99. The class width is the difference in any two consecutive lower class limits, and it's supposed to be consistent throughout the entire table if they've done it correctly. So I can grab any two consecutive lower class limits. It doesn't have to be, for instance, delete the first two. So I'm going to grab the 14 and the 16. So then the class width, I'm going to subtract those two values. 16 minus 14 is 2. Alright, so now that we have introduced some lingo when we organize our classes into intervals, such as the lower class limit, upper class limit, and class width, let's go ahead and apply this to a data set and make a frequency distribution and also a histogram. So it says the following set of data represents the family income in thousands of dollars rounded to the nearest $100 of 15 randomly selected families. So the data set says 46.5, 31.8, 45.8, 44.7, 40.9, 35.5, 40.3, 39.8, 65.2, 52.4, 44.6, 53.7, 48.8, 56.3, and 50.7. And then we're told construct a frequency distribution with a first class having a lower class limit of 31.5 and a class width of 6.2, then construct the histogram. So on this one, we are already told exactly where they want us to start the first class, and we're also told how wide they want each class to be. So that's the given information in order for us to start making our frequency distribution. Alright, so since I want to have a little bit more room to build this frequency distribution, I have this problem. I just repeated it on a new page. And I have the data that we're tracking here. Let's go ahead and start creating our columns. So we've got family income. And then for each one of our income categories, we're going to find its frequency. And because this data set is not necessarily sorted in any nice way, I'm going to build myself a tally column. So when we start getting our frequencies, I have a place to maybe record my counts. We're going to move this a little over so I'm not so close to my table. Alright, so we are told that we want our first class to start at 31.5, and I want the class width to be 6.2. So the class width will then tell me if I go to build the next consecutive lower class limit, it's how far away it should be. Okay. So we want to add 6.2 to 31.5, and then that's going to give us our next lower class limit. So 31.5 plus 6.2 is 37.7. If that's where I want this next class to start, then the previous class, or the first class, will have to end at 37.6, right before where the next class begins. And I only have to go out to the 10th spot because all of my data is out to the 10th spot. So this will appropriately capture my data. So I'm just going to continue in this manner, building up my lower class limits. Now I have to have enough classes to capture all of my data values, and looking up at the data set, this value right here of 65.2 is the largest data value in the data set. It's sometimes called the max. So I need to at least have enough classes to capture that maximum value. Alright, so then I'm going to keep adding 6.2 to these lower class limits. So I get the next lower class limit is 43.9. Then the next lower class limit is 50.1. 56.3 and 62.5. Now if I were to keep going, 62.5 plus another 6.2 would be 68.7. The largest data value I have was 65.2, so I don't need to go this big. I'm not going to have any data values that are going to be that large, so I'm not going to build that class. So right now I'm just going to put an X to show us that we were thinking about it, but that way we're going to omit it. But normally for your final frequency distribution, you don't include that information. You just don't build that class at all. All right, so then my second class will end at 43.8. because the next class starts at 43.9. My third class will end at 50.0. And I'm going to go out to the 10th spot just to be very, very clear. So then, you know, don't just write 50, write 50.0 so that everybody is out to the 10th spot. The next class will end at 56.2. Then the next class will end at 62.4, and then this is another reason why it's sometimes helpful to kind of put this number down and then omit it later, because this tells me that this last class should end at 68.6, because if I were to build the next class, it would have started at 68.7. Alright, so now that I have my classes, we're going to go through and start tallying. So, for instance, my first data value, which is 46.5, would fall in this third class. So I'm going to put a tally mark right here. So again, I encourage you to do this on your own and then verify that your tallies match up with mine. All right, so I'm just going to keep working through here. So 31.8 is in my first class, 45.8 is in my third class, 44.7 is also in the third class, 40.9 is in the second class, 35.5 is in the first class, 40.3 is in the second class, 39.8 is in the second class, 65.2 is in the last class, 52.4 is in my fourth class, 44.6 is in my third class, 53.7 is in my fourth class, 48.8 is in my third class, 56.3, now that's actually the lower class limit, but it definitely falls into that class. So this is going to be in the second to the last class, and then 50.7 is in my fourth class. So the first class has a frequency of 2, the second class has a frequency of 3, the third class has a frequency of 5, the fourth class has a frequency of 3, and then the last two classes both have a frequency of 1. Alright, so there's organizing our data set into classes where each class has an interval. So now let's talk about constructing the histogram. So I'm going to have my horizontal axis down here be the data that I'm tracking, which is the income, and it's in thousands of dollars. Okay, so if there's units on your data, you want to include it. My vertical axis over here is going to be the frequencies. The frequencies span from, looks like the highest frequency is 5. So on this axis, remember we always kind of want to start at 0 right here. So I'm going to count by ones, but every 2 boxes. So that's going to be 1, 2, 3, 4, and 5. I like to utilize the space that I'm given. I think it makes it a little bit clearer if we can make things as large as possible. So for my income, I'm going to need enough rectangles in order to build my 6 classes. So I think I'm going to be able to fit it if I make every rectangle 2 boxes wide. So again, I like to plan it out before I start drawing them. So I'm going to draw out enough tick marks. 1, 2, 3, 4, 5, 6. Okay, so I'll be able to fit 6 rectangles along there. And so now let's figure out the height of each rectangle. So the first rectangle needs to come up to 2. The second rectangle comes up to 3. Notice I'm not labeling these rectangles right now. We're going to talk about how to label it in just a second. The third rectangle will come up to 5. The fourth rectangle comes up to 3. And then the last two rectangles both come up to 1. Alright, so these are my rectangles. Now, because each one of these rectangles represents an interval of values, there's a couple different ways that we can label the rectangles. One of the ways to do it is just to label the rectangle with the class interval information in all of its glory, meaning provide people both the lower class limit and the upper class limit. So what I mean by that is the first class goes from 31.5 to 37.6. The second class goes from 37.7 to 43.8. And you would continue in this manner, labeling all of your rectangles with both the lower and the upper limit. Now some of this gets a little bit redundant because you can see then I don't really need to give the upper limit as long as I know the lower limit of the next class, right? As long as I know where the next class starts, I can then assume that the class right before it ends right before it. So because of that, instead of giving both numbers, sometimes by convention we only give the lower class limits. Okay. But this is one way that you could label your rectangles or your bars. You could give both the lower and the upper class limit. Alright, so that's one way to do it. So maybe let's try to summarize because I'm going to show you one other way. So here are some options for labeling the values. So I've got kind of two snippets. I'm going to draw my axes in here. Okay, so I'm going to have frequencies 1, 2, 3. All right, we're not going to repeat the whole thing. I just want to kind of show what's going on. So my first bar came up to 2. Then the second bar came up to 3. That first bar went from 31.5 to 37.6. The second bar went from 37.7 to 43.8. So this convention for labeling the bars is to give both the lower and the upper class limits. Just give everybody all the information. But because some of the information is a bit redundant, if someone was comfortable enough kind of being able to understand that the next lower class limit will occur right after the previous class ends. So again, I'm going to repeat my rectangles. I've got my first rectangle that went up to 2. And the second rectangle goes up to 3. The other way to label these bars is just to state the lower class limit but we're going to, when we write it, we're going to align it to the left of the bar. So what I mean by that is this first class started at 31.5, so I'm going to write 31.5, but I'm going to align it to the left of the bar. The next class starts at 37.7, so I'm going to write 37.7, but again, it's going to align to the left of the bar. And I would then repeat that process with all of the bars. There's pluses and minuses to both methods. You will probably see both methods in various graphical displays in different sources. The one where we only provide the number to the left of the bar probably happens a little bit more in context when we're looking at statistics in a formal statistics course, but I think it's important that you know and be able to read both of them. All right, so if you're not told to label it in any particular way, it's not wrong to provide both the lower and the upper class limits. But again, that information can sometimes be a little bit redundant, and to maybe eliminate so many numbers on the graph, we sometimes can just get the lower class limits. A couple of things to wrap up our histogram. Let's go ahead and give it a title. So let's call this, you know, I don't know, family income. All right, so we have a beautiful title for our graph. Notice that I have both axes are labeled. Because this needs to be a histogram, the bars are touching each other. We have consistent spacing both in each bar, being the same length, but also on my vertical axis, the distance between tick marks is consistently being measured off as 1. And then the final thing on this is that we're labeling the classes appropriately. If your classes only have a single value, you can put the label right smack dab in the center of the bar. If your classes are an interval of values like we've been dealing with right here, you can label your bars with the interval, and again, those are usually put in the center of the bar, or you can just record the lower class limits, but if you do that, they would be always aligned to the left of the bar.